Okay, so while we just wait for one of the speakers, I'll just give a brief introduction here, what we're doing. So as I iterated before during the workshop, the idea here is to have some kind of community discussion where we gather people. We have a good number of people here, and then we just talk about certain problems that we have and try to brainstorm solutions. So the idea is first to acknowledge what was done in the past, then understand what the problems we have now, and then try to brainstorm some solutions. And hopefully in some ideal case, we can come up with some notes about what we talked about and have some either like a one-page description or multiple pages as some kind of output of our workshop. So something like jointly produced by the community. I think that'll be really interesting and valuable for guiding our research and so forth. Now this time, since we also received some number of lightning talks that were on a similar topic, we decided to go with what are the problems with integrating modeling into more complex systems. And we have several lightning talks on this topic, and we hope that we will, as I said, like come up with something interesting. And this is just like also an experimental thing that we want to do, because like as a workshop implies that we're building something, and I know I have some friends in like visual arts or music, and for them workshop means something completely different. It's not like a conference, it's really like gathering together and trying to either improvise something or make something together. So it doesn't really directly apply to us, but I think this is like one thing that we could do. It also tries to make the online setting a bit more interactive. So let's see if we have everybody here.
I think we're still missing Tears.
Yes, indeed. Okay, so what we'll do, we'll just wait for maybe just one more minute, and then we'll just start, and then maybe they'll join in the meantime. Okay, so throughout the session, I'll also be making some notes. All right, so I think what we can do, we can just maybe start. Maybe we will just start, and Theos will hopefully join us shortly, and then we can just come at the end. Okay, so here I'm happy that we received some lightning talks, and here the first one will be Gottfried. I think this talk is really great. It's really related to this topic and also relates to some of the talks from the workshop today. So please go ahead.
Thanks, Emil. When I read the call to vent my spleen, I didn't know that expression. I was really glad that I have the opportunity. So my topic would be the short talk would be why do I have to model everything twice? So that would be the short. The long topic is why isn't there more support for object-oriented models in constraint models or constraint solvers? Object-oriented models are widely used within industry and other software projects. For instance, I'm from a Siemens department that specializes in product configuration. We typically model our things with object-oriented model. By object-oriented model, I mean this in a very broad sense. This can be UML-like models. This can be RDF, OWL model ontologies that are now popular with knowledge graphs, or just some maybe even JSON schema, whatever. The problem is there are some languages, constraint languages. They are the air quotes constraint languages for these formalisms, like OCL or Shape, which is for RDF. It's a shape constraint Shackle, which is a shape constraint language. But ironically, there are no solvers. So what can we do? Constraint programming for the rescue. Constraint solvers. But what happens then is that there is very few support currently available if you want to start. And for instance, take this primitive object-oriented model where you have some classes, attributes, and especially associations, and want to model this in a constraint solver like a MiniZinc model, which I have done here ad hoc. So one of the problems with encoding an object-oriented model is that we typically don't know the number of instances we will have in our solution. So in general, we might have only one parameter and say that all objects are optional. And if we have such a thing, then everything else also becomes optional, because in the worst or best case, depends on the view, maybe you have an instantiation without any objects that satisfy all your constraints, or you have an instantiation with hundreds of objects that satisfy your constraint. So that's where, to quote the call, the model becomes awkward. And another problem, of course, is grounding. If we have a lot of objects, although the problems themselves are often very simple, the grounding may explode. For instance, we have also experimented with answer set programming, and typically there we have this problem. If you have a lot of instances, then maybe the grounding may become an issue. So yeah, that's about my lightning talk, and I hope that we can figure something out, some support from side of the constraint programming community, that I don't have to model everything twice. So.
Okay, great. Thank you for this talk. So how this will go, we'll just have a series of lightning talks, and then afterwards we'll have a more engaging discussion.
Okay.
So thanks. This was clear. So Tias, you would be next.
All right. So my lightning talk is called CCP API, and I'll. It's
a great name. I like this.
Yeah.
For sure.
A lot of effort went into coming up with the name. So can you see the screen right now?
Yes.
All right. So it's the question was, what really bugs me about
we just see the title.
Sorry.
We just see the title.
Yeah, that's on purpose for now. And so it's so that there is no common C++, C++ API. CP, C++, wow, I'm even struggling already. All right, so no common API for the solvers. And so the reason, so it may not really be about modeling, but I think it is about modeling. And so we started building this kind of modeling layer tool, CPMPy, and for that, we want to interface to solvers. But and if you interface to set solvers, for example, many of them, they adopt the MiniSet API. And that means that if you have some code, you might actually be able to use different solvers in it. But for CP solvers, there's not really a clearly agreed on formalism or API or something. And I think that's a miss, because so if you look at languages like Essence Prime or at MiniZinc, then it uses a text-based file format, which is great, but that means that solver developers need to write file parsers, and then they need to map it to their API, and that's a bit, yeah, that can be not something that people that develop solvers really want to do, nor people that want to use solvers. Also, reading and writing files can be slow. So when we do repeated calling, this is actually creating some overhead that we could avoid if there would be an API to talk to straight. And then the main point is that I think not having an API is kind of setting us back as a community. And I think we could be much more innovative if there would be a shared API between the different solvers, so that people can work at more high-level algorithms and swap in different solvers in and out of that. And so I think it might be good to come up with a common CP, C++ API, so that we can do API to API communications. And I don't actually know what it would look like, or I don't have a concrete proposal because I'm not a solver developer per se. But if I look at the way that we are using solvers, I do think that there are kind of like 3 function groups. And so the base way in which to use a solver is to create variables and constraints, and also an objective, and to call a solve. I think another group of functions ideally would be about incrementally solving. So the fact that you can call solve multiple times or have assumption variables or something like that. And then the last part is about specifically getting an unset core for solvers that support that. So I think there might be 3 different instantiations of such an API. And at least I think having something like this would be helpful to actually a lot of the modeling language developers. And that's my lightning talk.
Mm-hmm. Okay, great. Okay, thanks for this lightning talk. Yeah, I think it relates also to the first one. And I think Graham will also tell us something about his problems.
Sure. Yeah. So I'm afraid I don't have any like slides or anything. But so this actually ties fairly closely to the stuff that T.S. was talking about. Because so we have all of these modeling languages and solvers that are great for one-shot solving. But when it comes to incrementality, the functionality is pretty limited. And so at this point, we've gotten to the point where, okay, maybe we can like build a model and we can add constraints. And so if we've got a SAT solver or a lazy closed generation solver, we can like add some new constraints, we can resolve, and we get to reuse most of the sort of like anything that we've learned previously. What we don't have is sort of column-wise incrementality, right? So we, if we're trying to solve a like online scheduling problem, then once we want to start sort of adding tasks dynamically, then we're adding new variables that like may not be strictly constraining the problem. Then, okay, so Alex is in the audience. Alex is working on like an extension of MiniZinc to open constraints, but that's still pretty restrictive. And like the sort of so what Torsten was saying in the morning about SAT solvers, the sort of killer application there was model checking. And with that, you're doing sort of partial unrolling. And then if you find an unsat solution, then you're going to unroll it further. And once we start trying to do this weird stuff and like adding new variables that sort of relax the problem instead of making it harder, then we basically have to give up on our nice modeling languages. So what we don't have is like a nice sort of incremental interface for expanding things in a reentrant way, basically. Yeah, and that's really annoying, but I don't know what the language would look like that would support that.
Okay, great, thanks. So just like to conclude here, I'll also say something about that I'm a little bit bothered with, is that when we're comparing solvers, we can take a problem, model it in some problem, and then we compare the performance of the 2 solvers. But behind the scenes, the solvers might do some pre-processing. And we don't know actually what the solvers do. So when we compare the 2, we just see the end result, but we don't know actually what kind of pre-processing went into play. So it would be nice if we could, maybe this TS's API that we proposed, maybe we can extend it with also allowing for pre-processing too. So that we develop, let's say, a pre-processing tool that we can use among other solvers. And that would help us in several ways. Like one is that we would have a better idea, like at least we would reduce one of the variables when comparing 2 solvers. The second one, we would be able to reuse really good pre-processing techniques. And the third one, I would also like to know that this preprocessor tells me like what it pre-process, so that I understand if it's rewriting a constraint, for example, or if it's doing something clever. Like I would like to know exactly what's going on. And fourth is like if we're doing like something like modeling a problem into SAT, it would be nice if we can do pre-processing on a CP level, high level, do the pre-processing there using global constraints, and then we can use this like pre-process model to model it as SAT. And then it will just help us a bit understand better exactly if this is, for example, useful. If SAT performing better on that, then we know that the technique they're using is somehow very useful. Yeah, so just like just a short comment, I think that would be really great. We know that in MaxSat there is something like this, like a tool that pre-processes, but still it's not really in the API-friendly kind of level. And we know that MiniZinc in essence do some pre-processing, but not to the extent of, for example, some solvers. So it would be nice that we have that unified. Okay, so that was my my lightning talk, and now we are concluding the lightning talk session, and now we will start the discussion here. So I see already there's some discussion in the chat. So if anybody needs to leave, we'll come back, but that's fine. So you can just go in and out as you like, and we will occasionally make some summary points. All right.
Unless anyone has suddenly been inspired to give an additional impromptu lightning talk, that's also welcome.
So this discussion point is a bit free form, so we can do this in different ways. It's easy if you turn on your camera and just talk, and then we can try to have a discussion like we would at a conference, for example, sitting at a round table. So I think that we have several interesting points here. We have that it would be great to have some kind of API to move away from text-based representations, would allow us to incorporate this in many different, it will be just easier to incorporate this in any kind of system. Would be nice if we can model things in object-oriented programming, which I think also makes sense. So today, like, for example, I've noticed Peter's talk is introducing enum types, extension enum types. I find this kind of in that direction. It's like very convenient for modeling. Like it's like going from procedural programming to object-oriented programming. I think there's some value, even though it's seemingly more complex, but it's just easier to parse. And also help, like in Gottfried's situation, for example, where they have these modeling formalisms, but there's no way to solve them unless you write your own modeling. And then hopefully this API would help with Graham's situation with incrementality. It would support that, because it's true, now you solve a problem, and then if you constrain your upper bound, you solve it, you want to add a new variable, well, you have to resolve everything or add some assumptions, or it's not like a standard thing to do. And I think in MaxAd, they're trying to kind of also start doing that. Like in the competition, they had some things where you have incrementally call the solver many times by adding some upper bound constraints. And so please. So go ahead.
Sorry to interrupt, because what I also think, okay, it's what I also think is that it was benefit to attract non-experts from constraint solvers to use constraint solvers in their daily work, because for instance, one motivation for my talk was a while ago someone contacted me. He had no constraint background, whatever, and he said he wanted to model a simple. He has a computer and some monitors and cables, and he wanted to model this in a constraint solver, and I really had a hard time explaining this to him. If he already had some JSON data, so he had his model already there, but to map this to MiniZinc, for instance, this was a barrier that was much too high. So yeah.
Okay, so I see we have lots of things going on in chat. We would also need to discuss that in voice, but let's first talk what just Gottfried said here. So what do you people think? Like, is this kind of mapping from JSON or another object-oriented programming language, object-oriented view to MiniZinc, is this something that we can do? Or is this like too difficult, or just nobody has time, or it's not valuable? Like, what do you think?
Can I interject here? We need to actually get a bit more specific about what is meant by the API. So if one just wants JSON, then of course some of the constraint systems out there already support JSON as the internal representation that they use to talk to various research tools with. So you know, Conjure, for instance, it outputs JSON, can input JSON if you want. So Saad Atti's work on incremental solving, for instance, just used Conjure as a parser, output the JSON, and then read the JSON and worked with that. So that's a very crude way of seeing an API. I mean, it's just a very simplistic, you know, basically saying, give me the tokens in that the parser has generated. But there's clearly something else going on here. So Kieran in talk kind of mentioned this, sort of hinted at it, that you know, you really want to kind of capture some common subset of constraints, a bit like maybe what SMTlib is doing, sort of saying, well, here are the high-level primitives that we want to support in the API, and that might not be the same as what the solver supports. The solvers might have a totally different set, but at least it gives us a common basis. And I think we've tried that in a number of different approaches already. Not really the same thing. It's not an API, certainly not machine callable, but and I'm not sure if we're ready to. I don't know. I mean, the point is SMTlib was terrible, and then they revised it and became SMTlib version 2, which is what everyone's been using for the last 15 years. But SMTlib 1 was terrible. It was just awful. So maybe the point is just do it, see what breaks, what people don't like, and then fix it.
Mm-hmm. So could you just give us some context for like what is SMTlib doing so special, like the second one or even the first one? Like what's the what are they doing that like we are not doing?
The point about SMTlib is it was meant to be a higher level Dimax format. So Dimax being the SAT solver format, which is really simplistic, it just says here's a CNF. It doesn't do anything else. It's got no other features. And SMTlib was really saying, well, we want to add a few things that everyone wants to use. And as an afterthought, for instance, they added all different that they called injective. And this wasn't even supported in SMT solvers for like until 2010, I think, when one of some constraints people went and actually implemented the proper way of doing all different in SMT solvers, and then the thing just went much faster for those kinds of problems, because that just wasn't a major concern of that community. But the point about all this is really that there was a consensus that at least some commonality was important. And I think right now we've got very different ways of seeing the world. We have MiniZinc, we have C++ code inside various different solvers. We have OR tools, we have SS text files in JSON, and they are very different. These are different ways of looking at the world, and SMTlib is a common way of looking at the world. It's a sort of a set of common abstractions that people can agree on, and it's a terrible set, but it allows people to have at least something in common.
Mm-hmm.
I see a hand up from Mikkel.
Yes, so I agree that it's very useful to be able to run the same thing on different solvers, and for that I'm really happy with MiniZinc. But at least in my experience, so I've been in industry for quite a while now, and I mean, solving a problem in MiniZinc is really just the first step, and it's almost the uninteresting step. The interesting step is interfacing to a solver and actually using all the facilities of it and configuring it and manipulating how you call it. So I would say most solvers today, it's not that we need to restrict their interface to just some subset of the least common denominator. We actually need to expand most solvers' APIs, because you need to do so much more with them. Because the really interesting part about the constraint program solver, in my opinion, for my use cases, this is very different from academic use cases, is that it's an easy and efficient way to get propagation. And if I can control propagation and then do something, perhaps do search on some variables, do something else, that's where sort of the usefulness of CP technology comes in for me in most of the cases where I do stuff. So while I'm all for getting more like common APIs, solvers are so very different, and they should be, in how they do stuff, that I'm worried whether, I mean, what more than MiniZinc say could we actually have that is common enough? And MiniZinc is really, really restricting in what you can do already. So that's more like my view.
So it's great you mentioned this from your experience. So you have like you give us like something like concrete, like you really need this being supported, for example, but it's not.
Yeah, so like you need to do large neighborhood search, but how you do large neighborhood search really depends on the solver, how the solvers implement stuff like backtracking, running stuff in parallel, all these different kinds. So every solver has a different idea on how you should implement large neighborhood search. But you also need to implement something that's a custom heuristic, in my experience. But that's also something that really needs to integrate into the solver's internals. I mean, I often want to have this in MiniZinc, but I know I can't really have it because it would be like an interpretive overhead that's just insane for most cases. I think somebody might figure out something magic, and then I'd be really happy. But I want to write a heuristic that guides my search, because sure, I could put everything into an objective function, but that would just run forever. What I want is to use a propagation solver, quickly get a good enough solution, and then exit. Because typically you only care that the solution is good enough. And with a reasonable heuristic and propagation that keeps you into valid solutions, then you're home most of the time. For most of the cases I've been working
You
with.
would like that the API supports some form of like more advanced program search where you can give more of your domain specific knowledge to the solver, and have that in an API.
Yeah, I mean, that would be the dream, but I don't believe in the dream, because each solver is so different. I mean, our tools and G-code and GEAS and Shaft and all, just if we're talking about the common C or Minion, the common C++ solvers, they are so different. They do things very, very differently. So I guess, and also I have the experience where we did a Java interface to G-code in the early years, and this interface made the whole solving process 10 times slower, which was really, I mean, it was a stupid interface. It used Swig and everything, but we really had to pull it because it was so bad. So propagation solvers, you have very, very tight inner loops, and if you try to mess with them too much, all the expectations fall apart. So I'm very, very hopeful that lots of smart people can come up with something, but I'm also skeptical, because what I really want are these knobs and buttons inside a solver.
But
so,
Mikael, isn't what you're saying a bit contradicting? So first you're saying that I want a way in which I can change the solver, but then you're saying changing different solvers will result in very different behavior. So isn't it more desirable to have one agreed entry point into a specific feature?
Yeah, that would be great. But I mean, solvers have all these knobs and buttons are typically tied to how the solvers are implemented. The solving technology underneath. If you have a copying and recomputation solver, that's very different from a trailing solver, which is very different from a lazy clause generation solver in what you actually want to do with them.
But then those parameters should not be in a common API. They should be in the solver.
Yeah, but they inform how would you write the branching or a heuristic function? How would you implement large neighborhood search? I mean, these are different. So, but
the large neighborhood search, if you like, I think there's many uses to a solver that are shared among them. In a large neighborhood, the simplest one is just you take a random set of variables, you give them you assign them, and then you ask solvers.
Yeah, sure, but I want to choose the variables.
Yes.
Yeah, I mean, I want to write code that chooses the variables, and then you have to integrate.
If you had like an API that has directly support to any solver, you could tell the API, here are the variables I chose, find me something, return. So that this is like this related to this incremental.
Yeah, I know. I'm wary. I'm positive, but I'm wary.
Sure. So if I understand, your concern is that since these solvers, like there's lots of internal things going on, that it might be very difficult to make like one common API that fits all of them, and that somehow
that's actually efficient enough to be worth using that API to implement stuff. So what I probably will be doing for some stuff is implement my model in MiniZinc and then write a custom G-code runner for that model that does stuff with the model. That will, I mean, this will be a horrible hack that depends on me being able to know exactly how G-code works. And that's of course not feasible for anyone.
But for example, if you want just the specific case of large neighborhood search, like with an integer programming solver, you could do that, or you could do that with a specific CP solver that has an interface, for example. Like okay.
But there are so many of these things. Heuristics are restarts, limits for restarts, no good learning, how you handle that, parallel search, portfolio search, and so on.
Yeah. So the challenge would be to identify what are the really core things that you need, for example, try to see if this maps to many other solvers, and maybe the API would have additional things that are not supported by all solvers, for example.
Perhaps, because I mean, really, this modularity where you can pick and choose different components and assemble them, I think it's a real strength we have. When you know your solver, you can do amazing things to solve a certain problem, apart from the modeling. I mean, the modeling is also super important, but on top of that, to actually solve practical problems.
Okay, so here's a question. Let's say that if MiniZinc, I think that there's some progress in MiniZinc, for example, for an incremental interface, I think. So does that solve the problem, or are we still missing something?
I don't know. I'd be really impressed if they make it work with reasonable speed. So I'm eagerly waiting the results.
Team that knows what's going on.
I mean, there's also difference. Graham might know something, but I don't know. I'm not sure.
I mean, like, so we've been, so the thing is, I got swamped with teaching, and so I'm probably not going to have time to like do any work on it. So we had like a prototype of a new bytecode based MiniZinc interpreter. So like, because like one of the big bottlenecks is dealing with text all the time, and the flattener is terrible. I mean, it has the advantage that it works, but it's not super efficient for any large models. So we built a like bytecode based interpreter. So we like compiled the MiniZinc model to a like bytecode thing, and then can run that with a better engine. And then that can hook up to a solver that supports incrementality. But even then it's like super experimental and kind of limited. And even then it depends on the capabilities of the solver, right? Because if you're doing incrementality with G-code, then like you can just create a copy of the state, add new constraints. And then if you want to retract, you just, you've got that old state there. Whereas if you want to incrementally add constraints to something like chuffed, there be dragons, right? You need to like reify everything. And then when you retract it, well, that propagator is still there somewhere because there's not any way to unregister a constraint. Which I guess is sort of exposing some of the same problems that we're talking about, right? Is that like different architected solvers have different capabilities.
But I think it's like if we summarize all these features in some like API, which is like some ideal, like ideally what we want to get in some magical world, for example, API that can support anything. And then like if we could have that, then it would encourage solver developers also think about like these kind of things, like how can they really support these things? So we define what we want, that'll be great. And then maybe not so many would initially support, but maybe with time we'll get more support for these things.
That's my hope exactly. So currently there's not even a uniform, like there's not even a standard way to say, okay, if you want to create an integer variable, this is the common way to call your function. Or if you want to create an all different and things that all of the solvers share, even that. I think that could be a starting point. But I actually interrupted Yip, who was proper enough to raise his hand, so I'm going to mute again.
Oh, that's okay. I would just say that I'm actually in an interface like this, right? I've been working on incremental interfaces from MiniZinc to solvers for a while. I think it's very, you have to be careful to actually, I usually lean the other way around. I wouldn't say if it's really hard to do something for all solvers, then maybe it's better to start with a more minimal interface and see how you can extend it, right? And I think a lot of power in MiniZinc, at least, comes from the fact that all the constraints that we actually support, you can rewrite and things like that. So actually saying, oh, we're going to define a minimum subset with which you can model is a very dangerous part, because especially if you also want to include other types of solvers like MIP solvers and things like that, because they only support one or two types of constraints. And then you need the implementation of the constraint suddenly to implement all these things. And often it's better to work the other way around, right? To get the interface to register which constraints are interesting or something like that, and then work that way around. And I think you can work similarly with search in some ways. So I think that's something that I've been thinking about and doing a little bit with the last few months. So you can similarly, if you actually let the solver tell you, right, oh, we know something about large neighborhood search and we can do it in certain ways, then that can actually give you information about what you could do, and otherwise you can emulate it in a different way.
So I just have now a related question. So if we would have this magical interface, would this still help us with this object-oriented modeling? Or is that something completely different?
I think that, oh, sorry.
Yeah, so somebody go ahead. I'm not sure who was talking. I saw Tias and somebody else, but I'm not sure who was it.
Yeah, Yip was answering. Yeah.
Ah, Yip, sorry. Okay, great. So it was your voice.
Yeah, I think modeling is a very subjective thing as well, right? I mean, in MiniZinc, we model in a certain way, and I've really been impressed by Tias's new framework, which does modeling sometimes in a very different way. And I'm not sure if we're talking really about an API to solvers, right? Then maybe we shouldn't really be thinking about how you want to model things, but how solvers want to know about things. And I think it's a very dangerous point to really talk about object-oriented modeling when solvers might not be thinking about it that way. And talking maybe in predicate logic or something like that might be a safer bet in that sense.
Yes, I mean, for me, there's not that much difference. It's just people working with object-oriented model, of course, think of instantiation of their object-oriented models. But like we've seen in the IDP system, it's objects and relations, and you can map this all to each other. The difference is more how, if you have already an object-oriented model, to give somebody guidance how to encode this in a MiniZinc model. And there are certain peculiarities of this modeling process, because as I already said, you don't know usually the number of objects you have. So you don't know, you have a lot of optional variables, and this is more, for me, it's not so much with this API, but it's more to have some how-to guide or some best practices, or maybe the patterns as we had in the talk today, or maybe some global constraints that support modeling relations between objects. Yeah.
My question would be, is there a one-to-one mapping from the diagram representation to conceptual constraints?
Yes, this is another one of the problems with these diagrams is they were invented mostly for communication of developers or software engineers. So the diagram is not the important part. What this is describing is to have types and to have cardinality restrictions for association between these types. So that's the, for example, in this bike example, all you do is you say you have a bicycle and the bicycle has two wheels. This you can express also in a relational in IDP by defining some cardinality restrictions, or in ASP with this also with this cardinality expressions, and that's more the important part. That to say we have objects and we have relations between them. I wouldn't focus on this UML stuff. Yeah. That's
yeah. Maybe you would expect that then programmatically you could write some transformation rules from this format to another format.
Yes, yeah.
But I understand that you need expertise in CP and in the format to be able to do that.
Yeah, and you need to know what was the target, and if I don't know how to encode it in the best way in MiniZinc, then there's a problem. Yeah. If there were something like a global constraint where I say, okay, this area encodes a relation between two types, something like this, just off the head, then I would know the target.
Right? You can make that function or that global constraint yourself. You can define it and then you can reuse it.
Yes, program. Of course, I could define it, but the CP community would be much more qualified to define this. So everybody could define it, then I get not one model, one best practices or patterns, but every model looks different then. That's one of the points I wanted to make.
All right.
Yeah.
So the point is you have these like objects. We can kind of simulate this in MiniZinc, for example. Probably in essence, I'm focusing on MiniZinc for no specific reason. So you can simulate that, and then we could write some global constraints that would try to. Yeah. Okay. So I'm also trying to think about how you would do that. So it's like you have a global constraint that's somewhat like a template in C++ that takes and inputs some. Yeah, I guess the question here is like how you define this class actually and these relations. So is this something that we just need, quote unquote, just need somebody who knows the two, like who knows CP and knows the other modeling, and then it can be done? Or is it something that's missing, like we're missing some type, special type or special API or these kind of things?
I think it can be done, but I'm not sure if it's that performant. In one of the problems we made a while ago, we made a very generic mapping, but the generic mapping is just a proof that you can encode the instantiation in MiniZinc, but of course it won't perform because it's in theory you could encode every constraint problem that is out there as an object-oriented model, so you would have somehow found the silver bullet if it would also perform very well. Yeah. So
but it performs in ASP. So for example, so you think it's like is that correct what you said before?
Yeah, we used also ASP. Some things are easier in ASP, for instance, if you have transitive closure or some navigational expressions are easier to write in ASP than in CSP, because in CSP, when you encode a relation, you have more or less an integer array, and then you have to, if for all, sometimes this element constraints or the array expressions will help you. But in ASP, of course, it's easier to write down because it also already has this relational syntax. Yeah.
So for that specific case, it's like we're missing a global constraint saying transitivity of some object.
Yeah, maybe there is also this graph constraint already. So for some special cases like Hamilton circuit, there's already something there. Yeah.
Okay, so there's a comment that connectivity require additional features. And transitive closure require additional features to the underlying logic to avoid having to go to second order.
Maybe.
Let's see. Okay, so there was a question by Kieran. So I think he liked this idea of object. I think he referred to, he liked and disliked this idea of object-oriented kind of modeling. It'd be nice if you can say something about that. Or like, yeah, now you're having like, there's a discussion here about what's a variable in a solver, for example. Can even an API exist? Because maybe different solvers interpret the variable in a different way. because you have views and these kinds of things. So this, yeah, could be a problem. But I would guess that if you make an API and with some meaning, maybe it's up to the solver to realize that. So is there like, yeah, so just what do you think about that? Like, is it possible to even agree on like what is a variable, for example, in a solver? Mm-hmm.
Ah, that's a shame. I was just going to suggest that Kiran maybe takes the mic because he has good feedback on the chat, but it seems that he just wrote that he can't put on his microphone.
I can try, but I may have to turn this off if the drilling starts again. But yeah, so my worry is if you come up with an API that restricts us to a very small set of features, we end up with the problem that the SAT community has, that everybody knows that CNF is a dumb format, but also because they use the DMX format everywhere, nobody is switching to a better format. And we have even things like views mean that none of the major solvers really agree on exactly what a variable is, let alone complicated things like search.
Yeah, so if I look at the way that we use set solvers in our lab, we just use BiSat. We don't write CNF, we don't write. And in this BiSat library, you also have functions that do encodings of cardinality constraints. You can do assumption variables. So although you say that CNF is a bad format, by just using this library, we don't really encounter much of that, I think.
Okay, so you're saying that, so in this specific case for SAT, it's hidden away from you and you don't see the CNF problems.
Well, you have to give it CNFs actually, but you can generate them.
Yeah, but you have these like methods to generate.
Yeah,
like translate a high cardinality constraint, for instance.
Yeah, but also I think BiSat as a library is successful in having a single interface to, I think, 8, maybe 12 different solvers, SAT solvers, and they don't all implement the same API, but with a few translations in between, it does support writing it to all of them. I think that's a nice example, actually.
And can you use it incrementally too?
Yes,
like
yes.
You can get unset cores and these kinds of things.
Yeah, you can. Well, you can use assumptions, unset cores, and for the ones that support incrementality, it's automatically incremental. Yes.
I do think there's a very big difference between SAT solvers and CP solvers, right? I mean, when you're only talking about Boolean literals and clauses, I mean, that's a very, I mean, even if you then build on top of that with incrementality and unset cores and things like that, you're still talking about a very limited sort of subset. But if you, I mean, even if we assume that most CP solvers are talking about integer variables or interval variables or things like that, I mean, there's so many things that you could be doing and so many different constraints that you can be implementing. And every solver wants their constraints slightly differently. I mean, it's really tough to then compare that to something like BiSat, where, I mean, they probably implement 2 or 3 interfaces to set solvers that all work exactly the same way, right? They just have to give them clauses and then get their solutions back in one format or another.
Yeah, but we just have one. Okay, so if we talk about finite domain integer solvers, we just have one additional variable, namely the integer variable, and then a range of constraints. But yeah, I mean, just defining a common API among the common constraints should be doable. We can still have the special cases as well, but shouldn't we be able to do better than currently, where everybody starts from scratch?
Is a Boolean variable an integer variable or a separate type of variable? That's one of the annoying
things. So that will be up to the solver to decide.
But you choose that, yeah. I mean, if we say that the API should have just integer variables, then the solver will have to check that it's a Boolean, that it's only 0, 1. If we say, okay, there's bool variable and integer variable, and it doesn't care about Booleans, then it will just say, I encode it as an integer variable.
So I just want to add here. So it's like, it's clear that, okay, there are lots of problems But still, for example, we have these like the modeling languages like MiniZinc or Essence that still manage to interface lots of different solvers. So you have this declarative, and then you do that. So it seems like, so I'm just like wondering, can we identify at least why can we do that, but not do this API, for example?
I would say it depends on the goal. I mean, if you just want to model stuff, then you can use MiniZinc or Essence.
Mm-hmm.
But the goal of an API is to get, in my view at least, perhaps others have other ideas, would be to gain more flexibility, or perhaps just DevOps reasons, because it's cumbersome to integrate toolchain like MiniZinc or Essence into a Docker container, say. I mean, it's doable, but it's several extra steps compared to one program. So what is the goal? Do we want to be able to do the same things as MiniZinc, or do you want to do more? So, yeah.
Well, I guess we would like to do more, but can we do? I guess Yip can also tell us a bit here about, like, just maybe reiterate on the. Just a second. So, Kieran, did you want to say something? I'm not sure.
Yeah, sorry. I'm not sure I'll get cut off here, but I'm not sure whether we want to do more than MiniZinc or whether we want to do less than MiniZinc. Perhaps the question we should be asking is, if we had a very minimal API that forget incrementality, forget specifying your own heuristics, etc., that just let you write variables and a few constraints. But you could do this inside C++ without having to go through text files or MiniZinc or whatever. Would this actually be useful? I guess TS seems to think yes. I both really like this idea and really hate this idea, and the part of me that really likes this idea thinks that yes, having something small with just integer variables, just a small set of constraints, that would be great. And the part of me that hates it thinks that no, if you're using a solver, then you need access to all of the internals. You want the full functionality that the solver gives you, which is not really something we can abstract into an API because every solver is different. So,
yes, I don't think there should be one API that's limiting, right? There should be a base API. And I think that would stimulate ModRef research, because currently I see two main ModRef platforms, which is MiniZinc and Essence Prime. And if you want to do things, you either have to fully go into those, while if we would have another API, people could do it in another thing. In my case, it's in a Python embedded languages, but in another case, it might be in a Julia language, or it could stimulate, those kind of things.
So what you're saying is we have some API, and then solvers can then offer more, like they can offer additional functionalities, but try to agree on some core subset, and then solvers can add more things if you need, but at least they can try to agree on some small subset.
So that was exactly what I was sort of referring to, where solvers are supposed to register their capabilities, right? And that's sort of what the MiniZinc library at the moment does, right? In the solver, in this case, registers which built-ins it has, and then anything else is rewritten. And I think that is also the part where then the modeling language has to come in and actually, or modeling tool, or however you want to use it, I suppose. But that's where the modeling tool has to, at some point, also do some work to actually make it to the solver.
Okay, so can we, let's say we need to try to agree on what's the problem. So I don't have a clear image in my head of like what's the limiting factor. So when you said MiniZinc has to do these translations, I'm just like wondering if you can elaborate on that. For example, SAT solvers, they have this incremental thing. It works. Of course, it's much simpler in SAT solvers because there's only a few things you can really do. But with CP solvers, you can do many things. So that's true. But what prevents us from doing the same thing as a SAT solver in a CP, but just like the basic functionality, like that like just call the solver, get the core. like I'm sure that like this Python interfaces for several solvers, like or tools, I guess, and some they already have this. So like you can probably call them. Haven't checked, but I would guess that they have this functionality for a specific solver. And I'm just like wondering, is it really that different for different solvers, like that part? Maybe Graham, you also have you developed like a Python interface, right?
Ooh, the Python interface is very fragile, but like the Python interface was a very small shim on top of the C++ interface.
Yeah.
But so I think taking your example of getting a call, right? So once if you're calling a solver and getting call back, presumably that means that you're going to do something with that call. And probably what you're going to do is you're going to modify your original problem, and you're going to like resolve it with different assumptions, or you're going to add new constraints, or you're going to add new variables and relax some things. So like if you're wanting to use one of these, so I think this came up, with a couple of people in the chat, but so I think the sort of killer application of one of these APIs is going to be incremental solving or some sort of like programmatic control.
Yeah. So the main thing here that we have is that the API would be mostly for an incremental kind of use. So we can agree on that, that's the use of the API. Otherwise, we can just model and solve using already existing modeling.
In at least the experience we've had is that the place where there's a real pain point is the incremental solving, and it would be a great first step if we could get that going. So even if it would be a very limited API and maybe an API that isn't good enough for lots of other applications, it would be a great first step.
I would say a great first step would be getting variables and constraints working, which I don't necessarily think is quite as easy as we might hope.
Maybe just variables, forget about constraints.
Yeah. But from there, incrementality is just a matter of allowing to post constraints after a solve call as well, right? So I think if we get that right, I think we're on the right track. Yeah.
Usually adding constraints is the easy part, right? It's usually more about then removing some constraints again where it gets tricky.
But just being able to add some will already cover a lot of use cases. I agree that being able to remove them is a whole different animal and requires much more bookkeeping.
But removing it requires bookkeeping from the solver, not from the or for the API as well.
Yeah, maybe that's something that speaking as a solver developer, we just have to bite the bullet and do at some point because it's very useful, even though it's a pain.
I don't know. I mean, set solvers don't support removing constraints. If you want to activate and deactivate, you have to add implication literals, have these assumption variables. And that covers, I mean, they're happy as a community with that kind of approach, and we could have the same.
Restricting the scope of what removing constraints means sounds perfectly reasonable.
So I guess if we have just a minimal API, so I guess variables, primitive constraints that have to be reified so we can do the removal, assumptions, ideally cause, and then maybe some sort of a unified interface for exposing solver-specific extensions. And then does that cover most of what everyone needs?
I mean, I think it's a great first step.
That sounds like a good first step. But maybe, so just like Yip, since you worked on this kind of incremental like mini set, like, I mean, you also worked with like, what is it called when you're defining large neighborhood search?
So for my thesis, which I did sort of two approaches. So one approach was really to hijack the propagation engine of a CP solver and compile your heuristic down to something that is all done in the solver. So solutions and those kind of things are all processed in there. And the other one was really this incremental interface. So, I mean, what we were talking about just now is most of the approach that was taken. I mean, it didn't do anything about unset cores or anything like that. But the main idea was really that I can incrementally post constraints. And what we did was we worked with choice points. So we just said, initially you post all the constraints that can never be removed. Then you add a choice point, you add more constraints, and then you can retract to an earlier choice point again. And of course, you can do that with multiple layers. That seemed to work well. So we made an implementation for G-code, which was trivial because you just make copies of the state and then you can do whatever you like. We did a copy for chuffed, which was a bit, so that really just, as Graham was saying before, so the only thing it really did was just add, so it just half reified, so all with implications, right? So every constraint became an implication, and then you just use that as assumptions. So if the choice point was active, then it was set to true, and otherwise it was set to false for the rest of the run. So that just made a lot of garbage, but it worked well enough for most purposes in that sense.
Okay, so for example, what was just proposed, like it seems like you already had experience doing something very similar.
Yeah, so I think the main, so that there's two parts that we didn't really, or at least that we thought of differently. And so the cores is something that we didn't think about and didn't really discuss. The other part that we didn't, or at least that from the MiniZinc perspective, we do differently, right, is that we don't assume that there's any base constraints or anything like that. We assume that the solver provider will give you a library with how to rewrite things. So you only register which base constraints are there, and we just post them that way. So we always rewrite down to what the solver tells you to do, and then the posting function you just call with the correct names and arguments, which in that sense is different, right? Because if you're talking about a modeling API, then that seems to be slightly different. But again, I mean, it does play well into the sense that you probably want to be able to register extra functionality in some way. The question then becomes, how do you actually do something with that? And I think you sort of get this layered library, and it might be very tricky to get down all the functionality that you want, because you get to something like what MiniZinc actually does, I suppose.
I suspect no matter what we do, at some point the answer will always be, no, you have to go and use the solver-specific internals to solve that problem. And the question is where the line between, you know, this is something that is solver generic and this is something that is solver independent should be drawn.
But this, for example, what we discussed here seems like for the first step, like the variables, primitive constraints, so you can possibly remove assumptions, cores, unified interface for exposing solver-specific extensions. It's like, that seems like it covers lots of initial cases, and then, yeah, I guess we will have this problem of getting into the point where we really need to do something solver-specific. But at least in that case, we can just say, well, too bad.
Also, if you want to do something solver specific, you can. So in G-code, Guido did the start of an interesting experiment where you can actually write the plugin code in C++, compile and load together with your FlatSync file. That can do essentially anything to the solving process. I don't think there's been any actual use case of this, but in principle, you can do whatever you want. You can have your model in MiniZinc, and then you can write this plugin that hooks into the precompiled G-code solver and does whatever. So, I mean, that is a possibility where solvers actually can do. I mean, it's not unreasonable. And if you have this, an interface like this, the implementation of this interface, that is probably a much smaller piece of code to compile that you can actually compile and modify yourself. Compared to, I mean, I wouldn't want to put compiling G-code onto a sort of end modeler because it's complicated and takes time. But if compiling your own code plus some modifications of that, or this interface layer, could be doable.
So one of the difficulties I've found with this kind of API approach is parallelism. So if your solver is written in C++ and is inherently doing parallel stuff behind the scenes, like arguably modern code should, then this isn't something that gets type checked or anything like this. And it is very easy for consumers of the code to write something that makes some assumptions about the environment it's operating in. The big example here is the Python to C APIs are basically all completely unsafe if the C++ code is spawning threads. The only way you can totally safely deal with these APIs is by putting everything in a completely separate process and implementing message passing yourself. So the question is, if we're providing these APIs, how much do we say to the programmer that you must, for example, make sure that any file descriptors you open are close on execute? You must make sure that you do not hold mutex locks across solver calls. All of the difficulties of dealing with running in the same process as C++ code. And in particular, if we're allowing people to write plugins, it can be very easy for somebody to write a plugin that does something apparently completely innocuous, like opening a file handle and starting to write to it.
Yeah, I didn't say it was the solution. I just said that it was a possibility. So when we actually ran G-code in production, calling it from Java at the previous company, we ran it in a completely different process because it was not just worth it to run in the same process.
Okay, so this is a problem from the technical point of view. It's like, how do you ensure safety? Okay.
I think it's it's an issue of defining an API. That in some ways, a solver is quite a bit more than a library. If you have something that goes off and runs, say, for example, if you have a solver that does symmetry breaking and it launches an external program to do the symmetry breaking, so you have to do a fork and an execute. But because of how Unix works, that immediately means that everybody who's living in the same process space as you needs to know that the process might be doing a fork. Because strictly speaking, if your user code, for example, holds a mutex and then calls out to a solver, and if that solver then forks, this is undefined behavior and potentially leads to a complete deadlock. There's all sorts of deep weirdness that you have to be aware of when you're designing these kinds of APIs.
But how does it work? For example, like for machine learning, there's like Python APIs like that call different algorithms for machine learning. How do they deal with these things?
Mostly they are not robust. So mostly they will have random resource leaks. If you are very careful, Unix semantics are properly defined. So for example, whenever you create a file descriptor, there is an option flag you can pass into the file descriptor that says, close this on an exec or don't close this on an exec. There are APIs for if I'm holding a mutex, then this is what should happen when the process I'm in forks or execs. The problem is you're relying upon everybody knowing what these APIs are and using them correctly, which almost never happens. A lot of people will do. So a simple example is if you open a file and then immediately set the options flag straight afterwards, that will almost always work, but there is a race condition in there and you're in a 1 in a million situation where your process will deadlock and you will never catch this during testing.
Okay, so it seems to be a problem for safety. Yeah, I guess this is really a problem, but I'm just like wondering about, we would need to learn from these other libraries. If they ignore it and it works, maybe it's okay. Maybe if you occasionally crash, maybe it's okay. I don't know. It's really bizarre. But
it's definitely something to worry about, right? And I've had this discussion with Guido quite a few times, that I think the plan now for any sort of MiniZinc interface is that we will always first fork the process to actually run it separately, so we can deal with any solver abnormalities that happen, because there's so many that happen on a daily basis, and we just can't deal with any of them. And especially it becomes even worse, right, when you have a C API instead of an executable, because there's just too many things that can go wrong. And especially proprietary solvers and things like that, there's only a limited amount that you can actually influence them to do. So you do end up in a very tricky situation.
So I mean, if we are doing an API, is it vital we have an API that allows the solver to reside in the same process space? Or do we just define an API that inherently assumes it's talking to a different process? And I guess the follow-up question to that is, if we are talking between processes anyway and paying that overhead, then this doesn't necessarily need to be a C++ API. This can be an API in a bunch of languages for talking over. I mean, in the old days, there were things like, is it COM and these remote procedure calls for object-oriented languages that all seem to have died. But it could be if we're trying to enforce isolation, then we might want something along those lines.
I mean, there's definitely, I mean, you can define also just a binary format, right, to push through a pipe or something like that. That might be efficient enough, especially since, I mean, when we talk about solver times, right, it's not, files are annoying, but they don't cost too much overhead. There is something to say for actually, I mean, even if we use different processes, right? I mean, if it's the model that is the most amount of space, then you can still have that shared memory when you fork, while you don't really have that overhead for the solution that is being passed back over message passing. But maybe we're getting too much into the technical details at this point.
Personally, I'm very much in favor of simple, straightforward text-based protocols. Even if you then decide for performance reasons, version 2 of the protocol should go all binary and direct calling of and definition of data structures. But for me, a text-based, file-based protocol would be perfectly acceptable for almost all the applications I can think of, because the solver takes minutes to hours, whereas adding a constraint, I don't really care if it takes a microsecond longer.
The trouble there is, say you want to write something where you can actually implement heuristic. The heuristic will be called millions and millions of times per second. And that, then you really need something that is low level.
Yeah, also, yeah. Like even if you just want to do some kind of solution blocking to enumerate the multiple solutions, the overhead, at least in the current text-based ones, can be noticeable. But then again, like if we think about what is a constraint really, it has a function name, and then it has a list of either constants or variables. I mean, it can be a list or a list of lists, but that's basically the signature, right? So even this kind of API where you just say, okay, function name, and then has some list of lists of you know, that could already be something which is close to a text file, but it's not actually a text file.
Isn't that fairly close to what XCSP is internally?
In XCSP, you also, well, yes, I mean, I guess you could make an API out of XCSP. Yes, that could be possible. There's more than one, right? Because you can have like you can have simple expressions in XCSP, at least in XCSP3. But that could be a start.
Okay, so let's try to see like what. Let's try to maybe go through all the discussion we had and just like try to somehow summarize what did we conclude. So I guess initially that question, like one of the things we talked about was like whether the API is useful. I mean, in the end, we have this now question about whether text-based is kind of good enough and whether the API can be kind of simulated through sending text files. Is that what
very much as a version 1 prototyping thing. I'm not suggesting this would be a long-term solution at all, but certainly it would. I mean, straight away, if Mikhail's point about you know, you need to do heuristics, you need to call these things millions of times. If that turns out to be a very compelling, very common use case, of course, that needs to be. We need to move away from that straight away.
Okay, so we kind of agree that there should be some. That would be nice to have an API. Initially, it could be sending around text, but maybe later some better integration. You mentioned XCSP as a nice example, so I'm not familiar with it, but it seems like they're doing something semi-relevant.
I wouldn't necessarily say it's a nice example. It's an example.
Okay, it's an example. We've seen also SMT-lib as a quote-unquote terrible example, but they have some common core that they somehow build around. So it seems like we should come up with some API. We don't know exactly what and how it represents, but it's like useful. And then there are some technical problems like parallelism and like how to do the process spawning and these kind of things. I guess that's really relevant, but for the first iteration, you can probably try to keep that in mind. But I guess in the initial, when we're still defining conceptually what we want, we can just like hope for the best case that it's technically possible. That's my take. Yip has an interesting suggestion about choice points that he did in his previous work. That could be one way of removing constraints or adding constraints.
That's actually pretty close to what some of the SMT-lib solved. Well, the SMT-lib interface for incrementality, right? The push and pop.
So that's a good way. Like the core of the API is like some variables, some primitives, assumptions, cores, and stuff. So that we can remove things. Okay. Let's see what else we can agree on. I guess in the long run, we would like to do. Yeah, okay, so I think that's what we concluded so far. I'm also trying to think about this. So with this, that said, I just want just like maybe a final summary point again, just like how is this different from the Yip, for example, your work for Python for MiniZinc?
So the Python for MiniZinc is a very different sort of idea, right? So Python for MiniZinc is a driver around MiniZinc, but this would really be more of like a replacement of the FlatSync interface to solvers. And
okay.
Or at least that's how I think about it, at least. And I mean, that's, I think it links in well there, where, I mean, we would be looking at trying to do something different. I mean, we have been thinking about either binary interfaces or actually directly going into solvers for a while. So, I mean, I'm very interested in having this discussion even further and really trying to come up with a design for that. And I think all the functionality that we're talking about here would be functionality that we're interested in with MiniZinc as well. So really happy to have this discussion. I think the only thing that we might, or that I at least also myself think very differently on, is that I don't think that having the common constraints or things like that, that's something that I think, again, I like the capability-based system where you have a solver register under common names or something like that, the capabilities that they have, and not necessarily a modeling-based API where you can just assume that something is there.
Okay. Okay, I took note of that. Okay, so I'm thinking like what we could do is that I made any notes like what for our discussion here. So what I could do this week, or hopefully, or maybe end of next week, I could try to write up something from this discussion, try to make a summary, and then send this document to everybody who at least said something during this conversation. So we have the video, and then I'll try to summarize things, what I wrote down, and then you can also chip in and change it and so forth. And then maybe we can, yeah, do this, and then maybe end of November we can either keep it for ourselves, or we could publish it like on the workshop webpage, like as a possible output, like what we got, and then we could just slowly somehow go from there, because it seems like we all agree that this is great. It would be fantastic to have this, but we just don't know what we need to do actually to get this. So maybe that'll be a start, and then every now and then, every conference or workshop, we can meet and talk about it again, or do something in between. I'm not sure how to proceed. So it's like we are now open here. So it's like if you have any good suggestions what to do, that'd be great. So you said you're open to discussion about this. So yeah, so maybe when we see this summary document, we can try to arrange some other meeting or something like that, like this
yeah, exactly. Maybe so. I mean, there were definitely a few people that were interested. So maybe we can set up a small work group or something like that to meet after this at some point and see what we can come up with, maybe an initial design or something like that, and see where we can build from.
So I'd like, can you certainly make, I like the note of Kieran a lot, that actually the XCSP3 authors have already done part of the exercise. And so they chose to have a higher level format than FlatSync, for example, and a bit more standardized. So that could be a starting point to think about, okay, of course, in their case, it's an XML format, but what would a direct API version of this look like? And could that cover the kind of cases that each of us have in mind or not?
Personally, I would say my experience when I looked at XCSP was that it's more a modeling language in XML format.
It's in the middle. It's still,
but I mean,
low level, but it doesn't go all the way into Int'l.
Yeah, and that's the problem. So interfacing to it, you have to actually parse expressions, and that made it. So I looked at it and then I discarded it for. I looked if I wanted to implement it for G-code, putting on my solver implementer hat, and I didn't want to parse expressions, so I just skipped it. I mean, parsing expressions is hard and not a job.
Yeah, but so I'm not saying that we should take over the XML, right? I think
no.
Nobody here.
Yes, for the layer it is at. As a solver author, it was way too much work to work with. So that is one of the reasons I never wrote the parser for G-code for XCSP3. It was just too high level.
So I understand that, but we can look at the abstractions that they made without having to look at the XML. Huh?
Yeah, it wasn't about XML, it was the abstractions choice. And just my point was that it's too high level to be easy to implement on the solver side.
Because, I mean, you were talking about FlatSync, right? And even though the format might look less standard because you have all the different calls and things like that, everything does have a very standardized format, and it's all ground. I mean, there's no expressions that you have to do anything with anymore. They're all just constraints that you need to post, or variables you have to make. So in that sense,
it's just relations and variables. So, I mean, parsing XML, that I can throw a library at, but the contents of the XML was too high level for me to bother writing. So that's just what I wanted at that. For actually, as a solver author, what I want is something more akin to the FlatSync level of abstraction than the XCSP level of abstraction, if I want to make it easy for solver authors to implement.
I think that's a good point as well, right? Because you do want, I mean, a lot of people to implement the API. So I think especially for a first version, that's also one of the reasons why it's good to be sparing with like the functionality that you add, so people can easily implement it and that you get a lot of people to actually use it. Because otherwise, if you only get 2 or 3 solvers that can actually implement it, it's probably not really worth it in the end anyway.
Mm-hmm. Okay, great. That's a good point. Noted. Okay, great. So I think I think probably now is like a good time that we maybe stop. We have lots of ideas. We can process these. I'll try to summarize this and we can then see how to go further. So thank you all for joining. I think the workshop was a great success. I think the talks were interesting. We had invited talks. We had 60 participants in the beginning, and then it went down to 30 near the end, which I still think was great. And I think we had a really nice discussion here. The lightning talks were great. It gives us things to think about, like this API. And I'm also interested in this like objective-oriented kind of view of modeling, and maybe this API can somehow help with that, so that we can, we'll have to see how do these things work. But it seems like, yeah, we identified some common problems that we had, and hopefully, let's say within the course of 5 years, we can make those problems go away. Okay, so thank you all for joining. I copied all the chat from the workshop. We have these videos recorded, so I think we have lots of material if you want to go back to something.
All right, thanks a lot indeed.
Yeah, thanks everyone for joining us. I think it was good.
Thanks.
Thanks. Bye.
Okay, yeah. And
Yes.
I think also for the CP organizers who have been here.
Yes, yeah, thank you for
helping us with
You're
the
welcome.
recording. This was great. This recording was really great, because there were some times I thought to myself, oh no, we forgot to start recording, but it was already being recorded. So that was,
Okay. You're welcome.
yeah, and also you did well with the video too. So there was one video which we didn't expect, but there were no problems. That was great. Okay, so thank you all for joining, and talk to you soon.
Yeah, enjoy the rest of the conference.
Okay.
Okay.
Bye.